Dude, biology is awesome. Let's talk about non-disjunction. What is non-disjunction?
Don't know. Teach me.
Okay, we should know. That is when the chromosomes improperly separate in meiosis. Remember that if you have a problem or if you do non-disjunction, this is so hard to draw it sometimes. Let's do it this way. In meiosis, you do two sets of this, right? Meiosis 1, then there's meiosis 2.
Yeah.
There's meiosis 1's product, and then here's the product of meiosis 2, right there.
Which is basically mitosis.
Yes,
Meiosis 2 and
that's correct. Yes. Yes.
yes.
They look just the
I
same.
mixed it up in my. I thought I mixed it up in my.
Now, non-disjunction is basically when you remember how like you're supposed to pull maybe in meiosis 2, which is right through here. Remember how you're supposed to separate out those sister chromatids like that?
Yeah.
And these two are supposed to separate. One goes to the left, and then the other one.
Everybody sit to the left.
I know.
Right.
It's all good. One goes to the left, one goes to the right, correct? And so you should end up with a system like this at the end. But non-disjunction would actually result in a system that looks like this, where they didn't get pulled apart correctly, right? If you have your mistake in meiosis 1, if the mistake or error occurs in meiosis 1, then that means the rest of your cells would be messed up the entire way through. And it would end in such a way that you have this cell, it would be n+1, this cell would be n+1, and this would be n-1 and n-1. There's a great picture in your book that might help you with that. Make sure you've got that set. If you make the mistake in meiosis 2, it kind of depends on which cell the mistake is seen in. Is it seen on the left or on the right side?
Some might be Gucci, but
So this cell, these two might be okay, but these two might have a problem.
it's not good.
This is actually the root cause of some certain conditions, like monoploidy or triploidy, like Down syndrome, or other triploid conditions, not just necessarily, trisonomic conditions, not triploid conditions, trisonomic conditions, like trisomy 8, which is extremely deadly. The baby will die within like a couple of years. Trisomy 21, of course, Down syndrome, a disease or an issue that people live with throughout the duration of their life. You would see that the rate of increase of trisomy cases would be increasing for ladies that are older, but that would make sense because this machinery would be just a little bit older. So you might give rise to more of these non-disjunction events in a female that's a little older. Cool?
You know what happens to females?
It could happen in a male, but a little bit more unlikely. Sperm cells are regenerated like every couple of days, so that they don't really have that time, if you will. Let's see. I think I don't want to talk about that.
You're not great.
Huh?
I agree.
Sure, it's interesting.
What?
And Marco's blue cat.
Respiration.
Yeah,
Let's do it.
respiration.
I respire sometimes.
I'm sure you do.
I know.
Okay. That's just photosynthesis.
Sci-fi.
What are the reactants for respiration?
Well, yeah.
Nope, we don't have glucose, do we? Oh, we do. And O2? What is your products of photosynthesis? C6H12O6 plus O2, those are your products? So we see that they're direct reversal, so that would mean that your reactants of photosynthesis would be what? CO2 and H2O? And then the products of the respiration would be that CO2 and that H2O, right? Right? I think we want to remember just some little points that I always like to make that kind of are close between the two, maybe something that connects them together. In respiration, there's a point in time where you're doing the Krebs cycle, which is also known as the citric acid cycle, the tricarboxylic acid cycle, TCA. And then there's the photosynthesis. In that, there's specifically a space called, or a reaction series called the Calvin cycle. They're direct opposites. Remember that your Krebs cycle is producing a couple of things. It produces CO2, NADH, as well as FADH2. And it also produces
What does TCA stand for really quick? Sorry.
the tricarboxylic acid cycle. basically citric acid cycle. CO2, NADH, FADH2, and some ATP. Cool. And the Calvin cycle actually is the direct opposite because it's going to be using reactants that are CO2, NADPH, and ATP. So I really kind of want us to see that these two cycles are like going in direct opposite ways because in the Krebs cycle you're seeing a reaction that is highly catabolic. You would find it only in mitochondria. And then in this reaction over here in the Calvin cycle, you're seeing a reaction that is quite anabolic. And this, of course, would be in the chloroplast.
Light reactions are. Wait,
And these are not the light reactions.
I know.
The light reactions, again, are the reactions that are occurring in the thylakoids, which are inside chloroplasts. And they produce the ATP and NADPH. And they also accidentally produce O2, which of course is exiting through your stomata. But they produce the ATP and NADPH that is useful at this point right there. So your light reactions again are powering the Calvin cycle. And if you think about it, the light would have to be powering this because this is the only way in which we could ever power the anabolic requirements, or the anabolic requirements to power the Calvin cycle, the direct opposite of catabolism of glucose. I mean, if you're going to build up a compound and build up a structure, you've got to have the energy to do it. And you very well can't get your energy from food because you are the structure that's making food. Does that make, I mean, I hope you guys see it that way, that since plants are making food, they very well can't be doing what we're doing to generate the energy to power this reaction. Like, in other words, I can't go buy gasoline and then take it to the house in order to make gasoline. You can't operate in conditions like that. You have to have some unique source that's able to generate your food, and that source is going to be the light. Cool?
Because if we can.
Okay. Yes, it's true. Or our own energy. I guess that's food. Let me think. I want us to make sure about respiration that we realize that respiration could go one of two ways. When we look at respiration, everything is doing glycolysis, right? And glycolysis is aerobic or anaerobic? Anaerobic, which means it's occurring in the mitochondria or cytoplasm. Very good, cytoplasm. And then after we do glycolysis, there's kind of a fork in the road where a decision to go one direction could be made or a decision to go the opposite direction. One direction could be towards the Krebs cycle, the citric acid cycle, which is going to be an aerobic mechanism, right? Which of course would occur where? Mitochondria. And the other mechanism, of course, would be what? Fermentation, which no one likes to do because it results in the production of ethanol, which we don't get to do. That's something bacteria do. Or lactic acid, which is what causes the muscles to burn. This would be something that would be anaerobic still because it's in the cytoplasm. Now it makes sense that if we can't get to the Krebs cycle, then we can't produce excessive amounts of the NADH and FADH2 and ATP, which means that this would represent a high energy mechanism. And this right here would represent a very low energy mechanism, which is why when your muscles start burning, that's about the time you stop running, because you're producing low amounts of energy, right? And you'll notice that your muscles wouldn't burn if you're able to do Krebs cycle and you're able to have high oxygen endurance. Good? Okay. Let's look at maybe a sex-linked question, because I have one now. So sex-linked inheritance. And about sex-linked inheritance, let's work out a problem real quick. It says that they let me find a different problem. Okay. Let's say that there's a lady, a woman, that's X big T, X little t, for colorblindness, which means she is a carrier for being colorblind. And let's say that there's a male who is X big T Y, which means he is normal for, I don't know, sight. If you're supposed to say it that way. Well, we can do the cross with these two individuals. And when all else fails, I think a Punnett square is the way to go if you're ever shaky on doing these types of problems. X big T, X big t, little t there, x big T, and then a y there. Cool. And I could do this cross real quick. So I got x big T, x big T, x big T, x little t, x big T, y, x little t, y. Perfect. Just like that. What? Yeah, so you have one son that's colorblind, right?
Okay.
And then one of your daughters right here is a carrier, which is just like the mom was, because of course your mom would be made of two x's, your dad would be made of an x and a y, correct? You know, there's lots of tricks on this, and it's one of those things you kind of just, to me, have to develop over time. You know, like one trick is that if your dad has an issue and you're a guy, you can't ever get it from your dad. I mean, if it's an X-linked condition. So like if dad was colorblind, that necessarily wouldn't affect me at all. Because color blindness is on the X chromosome, and I get Ys from the dad. So, yeah. I mean, there's just little tricks, but, you know, with practice, and you'll see plenty of exercises like this on the website if you'd like. Cool? Me? Oh, yeah.